we could recover some stuff like that.
You mean instead of having the user to do the action and refresh, to have some kind of automation and do it ourselves and retry a few times if it still gives us error?
Possibly.
Well, actually, the possibilities are endless. It's up to you guys to utilize it however you want, right? And even add the context you want. It doesn't work for all of us the same, right? Here in Epignosis, we just use, well, that's not related to your question, but I want to say that here we just use the theme tag, right? We don't usually, use any other context information for now. So it's up to you to do whatever you want and to add whatever context it's useful for you, right?
Any other questions? No questions? If you still want to win prizes, scan this QR with another chance. We give 5 prizes today. 2 OpenConf. Who knows OpenConf? Okay. 2 OpenConf tickets and 3 Volt vouchers. So you all know Volt. Okay. So we 10 minutes to have a little break and go, you can go to the bathroom, have some pizza. We have some cards from Sentry with 3 months free trial. It's here on the table. So if you want to try Sentry, there's some cards. You can pick a card. We're going to be back in 10 minutes, okay? And the toilet is there. Yeah. The exit is there as well.
Των τραγουδιστών. Άμα το τραγουδιστών, ακούς κανείς. Πρέπει να το βάλεις εδώ. Αυτό.
Μήπως ξέρω να... Hi. Εδώ. Θα έρθω λίγο μπροστά για να βλέπω καλά, να βλέπω τι έχω. Are we good? Good? Εδώ. Εδώ. Δεν ξέρω αν φαίνεται πάνω. Okay. So I'll try to be as fast as possible. Like, this is gonna be some more or less a freestyle talk because when people ask me to take part in this meetup, I thought about something, then I thought about something else. So we'll improvise on the go. So hi everyone, my name is Theodore. I'm a software engineer. I'm working at Workable as a software engineer, obviously. And you can find me online on X, Twitter, how it's called, LinkedIn, whatsoever. And the main thing about me is like when I'm giving talks, I like to tell people stories. So today I'm gonna tell you one or more stories. So it has been a rough year, and at some point I want to find a new hobby. And I bought like a really mini Game Boy emulator. It's called Miyu. It's like the best $50 I ever spent. And the great thing is like you can play lots of games from, I don't know, some weird consoles from the 80s up until S1. And I spent a great amount on this thing. Like I loaded lots of games, played on this one. And one of the worst things I've got as a software engineer is that I'm getting intrigued about how something is built. Like I'm playing Super Mario and I'm thinking, how on earth they try to build this one? Or how on earth they squeeze so much functionality in a small disk? And then it hit me like, during the 80s and the 90s and the early 2000s, right now we're a bit spoiled, right? So you have a bug into production, you're like, okay, I can fix that, git push, and then it's into production. But during the 80s, 90s, early 2000s, people were delivering software through CDs, right? Imagine that. You were working, there's a team working there, and you ship your code, it goes into the factory, it gets printed, and then boom, no updates, that's it. Can you imagine that? How hard it could be? And I kept thinking about that, and to be honest, I was playing a lot a game called Tomb Raider 2, the second version. Yeah. So this game was brought in 1997. It sold 7 million pieces. Can you imagine that? How hard it could be? One shot, like one release, and that's it. And the game was actually amazing, like an amazing world, open space. You can actually go through the world, try to find out, to explore things. And also it was amazing because they have pushed the working force of PlayStation 1. By the way, who was unborn in 1997? Oh. Unborn. Oh, okay, great. So yeah, back in the days we had that weird thing. You can see the evolution of Lara Croft through the series. You can see the polygons as how they evolve into a more sexist gameplay character. And it's really amazing because they built the entire figure in 3D using this kind of polygons. And by the way, I told you I'm gonna tell you stories. So 1 month ago, I visited a place on northern Greece. It's called Evros. Out of the blue, I visited a village called Visa, and there was a museum about Kara Theodore. Kara Theodore was a real big family coming from that village, and basically every single person of this family was fucking smart. So the first one was a doctor. The second, his brother was also a politician, lawyers, stuff like that. The smartest, latest part of this family was John Argyris, who was a really, can I swear, Argyris? Can I swear? Yeah, he was a bad motherfucker. Like, he was born in Vorillas. Then he went to Germany, where he was actually started designing the Second Reich's airplanes. Hitler himself actually gave him access to be the president of the aerospace company there, but he refused. So he went into a concentration camp. He swam the Rhine, and he actually fled to the UK, where he designed the aerospace for the UK, and then he left. He went to the States, where he designed the first Boeing engine, and then he actually designed the first system that actually cools all the NASA aerospaces when they enter the atmosphere. And the great thing was that this dude actually invented every single 3D rendering software in 1960s. He invented the mathematical model in order to build 3D software. So Tomb Raider, Lara Croft was built on the work from this guy. And then back into the game, it was really cool to play around the game. They actually built a physics engine, right? And there's some weird thing there. So because they actually built the engine, and they actually had one update to do, there were like lots of mathematical calculations here and there. And at some point, there might be glitches, right? So as you can see, Lara Croft glitches, right? She cannot move. And they actually implemented something called a healing mechanism. So inside the software, there's a mechanism that identifies that the character is not moving. It's frozen. And what it does, it actually spawns the character into the closest square, and you can keep playing and so on and so on. And as I was noticing this thing, also there's a huge hack. If you've tried to Google or try to find out about this game, there's a huge hack where you can actually glitch the game and actually climb into buildings without trying too hard. And actually I kept thinking about this a lot when I noticed, and I thought, I have seen that thing. I have seen that thing in networks. If you have networks here and there, and one node dies, well, the network heals itself, and root gets trapped along the way. The same thing if you have ever read about the case engineering in Netflix, yeah, with lots of microservices here and there, you might have heard about self-healing automation, where once a microservice dies, then the system heals itself. You might have heard also about Kubernetes or Docker Swarm, everything that has to do with networks. We have that idea built inside software engineering, but this is a React meetup. So what about the UI part? Figma has a really nice use case. So Figma it's a really complex software. You can drag stuff here and there. There are layers, calculations, snaps, you name it. What Figma does, it's quite interesting. So if you drag something, and during the calculation part, if something gets snapped or there's a collision here or there, if there's an error thrown, Figma heals itself. It tries to find out the velocity and tries to find out where is the user dragging that block. And actually, the user does not notice a thing. It's completely transparent. And I kept thinking a lot about this part. So I tried to wrap my head around, and actually I named that thing as the Phoenix pattern. And I also want the definition, right? So here's the idea. We have an application or a system, right? The users are not using the system or the application as we want to do. We can track down what caused the issue, and we'll try to fix it without the user noticing. There is a huge question mark, though, or an asterisk. That might be an error, or that might be an intention, because errors are quite easy, right? There's an error thrown, we can patch it. Alex has had a wonderful presentation about that part. But we also want to track intentions as well. We want to find out the optimal way of users to actually use our application. And we'll talk about this later on. And here's the deal. If we think about React, we have like components, right? So we have building blocks, like Lego bricks. We can combine this thing, like creating bigger blocks and bigger blocks, creating complex applications. But what if we could actually self-heal a single component? That might be a really good pattern, like a really good idea to try and figure out, try to improve UX, try to improve our conversions, and so on and so on. And imagine something like Google, like someone tells you to build Google using React, and there might be a component like the search engine, right? When you try to search about something, there are recommendations coming from the system. But if you try to search something, Google actually tells you, hey, you looked for I have a Greek joke. So you looked for Paivakia in Vari, but you don't know how to actually spell it. And I'm showing you kindergarten stations in Vari, which does not make sense. So Google actually gives you the results that you are intended to actually see because that's the most prominent results and there's a typo there. E-shops are also doing the same, right? You might have had one item in your cart and then you forgot about that, right? And then you get something like, oh, here's a coupon code because we want you to make a customer, you want to check out. Imagine that this is a single component and the component tries to identify the intention and says, hey, we will try to push you forward because we want to find a way to convert. And here's the deal. If we think about React, I think 97% of the cases, it's all about the state. We can, if we think that our code is, super solid, most of the times we're prone to errors due to miscalculations, due to a failing API, and so on and so on. So we can make an assumption like most of the errors or most of the users not using the app in a prominent way is coming from the state. That's an assumption. Does anyone use React Query maybe or SWR? Yeah, cool. So React Query has a very similar, another fetching language as well, but React Query is quite smart on this part. So React Query actually self-heals. Once the network is down or the API is broken, you can actually say, hey, retry this call 3 more times, and if not, just fail. If you're using, it returns back some React properties like is loading, so the user cannot actually see a thing. They might see a skeleton or a spinner, but in the background, there are calls coming up together. That's a self-healing approach. Let me see what's the slide. Oh yes. So in a more, let's say, tailor-made example, let's say that we want to build a form. We want to submit a post or a comment, right? So for the basic stuff, we have a form, we have a button, we have some sort of input. The user writes something, keep writing and writing and writing, and then, oops, there's an error, or oops, there's the page gets refreshed. The user loses everything. So what if we want to apply this pattern inside the case? That might be quite interesting and quite easily as well. You may have seen drafts here and there. We can check just a minute. Yes. So the whole idea is that we want to, yeah, that's the actual part. So in order to do so, we can use IndexedDB. IndexedDB, it's a web API, so we can say, hey, you know what, every time the form changes, just take the input, debounce it, and set up to IndexedDB. So as the user types, we keep getting a copy inside IndexedDB. Once the user submits the form, we clear that thing and moving on. And finally, we can take that part and fetch it inside the form. The outcome would be really easy. So the user gets, is it playing? Yes. So the user gets typing. That thing, it's called the draft mechanism, but actually applies the same principles. We try to help our users don't lose track of their content, don't lose track of unsubmitted content, and so on and so on. Actually, something really easy we can apply on different parts here and there. And using the same approach, we can actually try to be a little more explicit as well. So here we have an error boundary. Alex, as I told before, has had a really wonderful presentation about error boundaries. But here, the idea is that we're not trying to set up some fallbacks, right? We're not trying to say, hey, here's a toast. Hey, this is not working. The whole idea is like, if we know the structure, if we're using TypeScript, or if we have an API call that's failing or an error is thrown, instead of trying and popping up a toast, we can actually try and monkeypot the state. So in this example, we have a feed, and one item of the feed is actually malformed. So once we get the results back, the user won't see that red block no time soon. So we can just remove it from the feed. The same thing if you have noticed, especially in the early days, Twitter was using the same technique over and over again because they had arbitrary text. So they were applying fixes and stuff like that. Instead of guarding their data, they were saying, hey, there's an error here, just throw it away. But the whole idea is like, if we're trying to fix bugs here and there, that might be quite boring as well. So let's try to talk more about intentions. As I said, bugs are something that gets thrown inside your code. You have a runtime error, a build time error, but let's try to be a little more creative on that part, trying to improvise a bit. You may have seen that applications can be extremely slow. Imagine that you have some blocks or links, and server-side navigation, client-side navigation, doesn't matter. And there's an API that's extremely slow, or a page that's heavyweight. What we can actually do. Once again, React Query has a really nice custom mechanism. So let's say that you might have an API that you want to call. You can actually prefetch it, set it up in the cache, and the user once get used, you can retrieve it from the cache and use it inside your application. In a similar manner, frameworks like Astro or Next.js, they have a preloading mechanism where links can get preloaded, fed inside the browser cache and retrieved as is. There's a problem here. How do we know that we want to precast something? These frameworks have different mechanisms. So you can eagerly precast or prefetch stuff, like you can arbitrarily start moving around, but we can be a little more creative on that part. So in 2018 in Google I/O, there was a really nice little library introduced. It's called Guest.js. So Guest.js is actually a Webpack plugin and a library as well, which does something extremely smart. Instead of preloading stuff arbitrarily, we can retrieve data from analytics services. Let's say Google Analytics or Heap or and so on. Now it creates small chunks that describes user journeys. So using a library or even a backend API call, we can be a little more creative. Instead of preloading everything in the background, we can identify the user's intention. If we have sessions in place and we know which pages are popular or which parts of the application need more care, we can do that. And I think that part might be quite interesting because, let's play. Yes, please. So, because we can provide UX per user, we can do really creative stuff, and we can actually also resources. Imagine that you have backend calls firing up without anyone actually using that stuff. In this example, I'm using view transitions just to show up how everything gets preloaded in the background and how everything gets replaced. So we talked about TensorFlow, machine learning stuff, AI is a big thing. Can we actually try to provide some AI self-healing mechanism where an error gets thrown and we track down that error and deploy something into production? That's a horrible idea, actually. Because, yeah, I don't think that can actually work. I have seen there's a really nice Reddit thread with .NET developers melting down from Copilot trying to fix some errors and replying into GitHub discussions. But yeah, that's a really long-term, a really long shot. So because we have lots of context, we have, especially for complex applications, that can be a hell. And deploying into production without no human assistance might be, I know, horrible idea. But we can have some small bits and pieces of AI. As an example, I have added this part, which I really like. This is from a service which is called Tab8. It's an analytics service. And it does something quite smart. So instead of letting AI drive the whole process, we can add small interventions inside our applications. Here, the application has lots of filters. Like it's an analytics so it has cities, countries, events, and so on and so on. But it has a really smart feature. So once you type something that it does not get matched against the filters, it says, hey, I'm going to ask the AI how I can actually resolve the filters. And we have talked a little more about we don't need to let AI work without context. So here we have a dot schema that actually describes the whole filter mechanism of that particular component. Then when something does not get matched, we can say, hey, this is the schema. We're using the AI SDK NPM package. So you can say, hey, this is the schema. Take the prompt and try to match something against that schema. And inside our component, we can say, hey, if we don't have a match, just make an API call, get the string result back, and then apply the filters. I have the same slide twice. Lovely. And the whole actual idea can be really complex. Like, if we want to try and implement that part over and over and over again, can be really hard. But the whole idea about React is also that it's quite verbose. So we have building blocks that are quite verbose inside our application. As an example, I have told you before that we have building blocks, Lego bricks, that we have components. Imagine now that you have a design system, right? This design system has cars, typography, complex components, so on and so on. So a front engineer comes back and says, hey, I want to build a page that someone designed. So here is the structure. So I'm going to place this command here and so on and so on, try to bring everything together. But the whole idea can be actually quite interesting, because if you have static components, then we can actually describe everything in a more data format, I can say so. So if we want to describe a page, we can say this is a flat structure where we have a top level component. These are the props. Following up, we have these children. We can add additional props inside, injected, and so on and so on. If we have one sort of definition like that, then we can actually be a little more creative, if we can say so. And as I told you, the whole idea is actually bringing everything to the user. So imagine that we have some sort of information about the user preferences. We can call the AI and say, hey, can you actually test which layout converts better on this persona? Which, if we can detect that there might be slow connections, and say, hey, can you try to make the UI a little more light, or try this component because it converts better with this user? And actually, I think that might be the use case, because we right now we have really static content. Like, we're building stuff, we're trying to make our users happier, I guess. We're trying to make better work. But I think this is the part where everything comes together, where we can provide something that's tailor-made and more less prominent to errors and bad experiences. If you're interested about that stuff, you can scan the QR code. That's a placeholder post I made in LinkedIn like 10 minutes ago. But I promise I will update this one. And I want to thank you so much for your time and patience. And post? No? No one? Are we good? Okay. Γενικά, επειδή το έψαξα λίγο αυτό το κομμάτι, το healing έχουν άπειρα πράγματα, αλλά είναι πολύ γνωστό, ας πούμε, στα δίκτυα. Αλλά σε εφαρμογές είναι από ψυγεία μέχρι κλειδαριές και πράγματα τα οποία είναι prone σε errors. Το έχω πει ένα